Why, hello there. I am Isaac Newton. I have discovered gravity, and along of discovering gravity, I have discovered laws of motion. One of these laws of motion is called the motion of action and reaction. This law states that for every action force, there must be an opposite and equal force. You'll be learning about this law of motion through this video with the help of my colleagues, Heather, Megan, and Asia.
What does this look like here? It looks like only Heather is pushing on the tree, right? No other force is available. Well, that's wrong. The thing is that the tree also pushes force upon Heather too, because if the tree didn't, she would accelerate through the tree, thus falling over.
Here we have force 1 and force 2. Force 1 is Asia, and she is pushing on the door. Force 2 is Heather, and she is pushing on the door with the same amount of force. Thus, the door does not move. Force 1 is Asia. Force 2 is Heather. They are both pushing on the table. But since they are pushing with equal forces, the table does not move.
Okay, so now we're going to be doing an action and reaction one. The action is going to be me running at Heather, and the reaction will be Heather falling down. That was the reaction. But if the same force was applied to both ends, nothing would have happened. Something like this. Ah! 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 Oh! Ah! Ah! Oh! Ah! And if there's too much force, something like this will happen, where the object who is applying force will accelerate through the object.
To push Heather in the wheelbarrow, I have to push with my feet on the ground against it and with my hands on the wheelbarrow with higher forces than they exert on me. If Heather pushes Asia, then Heather is the action to Asia's reaction. But when Heather pushes Asia, Asia pushes the wheelbarrow. Thus, Asia is not only the reaction of Heather, but the action to the wheelbarrow.
Here we have Megan swimming in a blue lagoon. The action is her pushing the water backwards. The reaction is the water pushing her forwards.
Our mateys here with another action-reaction lesson from Newton.
Action and reaction pairs can be done without touching each other. This is known as action-reaction at a distance.
The action, a cannonball pushes out of a cannon. The reaction, the cannon pushes the cannonball forward.
And what did you think, kids?
That's pretty neat.
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 In time. That's pretty neat.
That's pretty neat.
That's pretty neat.
That's pretty neat.
That's pretty neat!
Boss, pretty neat. Yeah. He's like, and what did you think of that, kids? It's falling me off. It's falling off. It's falling off.
It's like smooth.
Why did you draw it and then put it on my face? What is this? What is this? What is that? Okay. No.
Hold on, what do you mean my funniest voice?
Like, that's pretty neat.
Okay, so here we have Megan swimming in a blue lagoon.
Heather! Redo it.
Okay.
You got your line?
Yeah.
Brief moment.
Sorry, Megan.
I'm terrible at. Oh.
Tidal wave!
The action is her pushing the water behind her.
That's pretty neat in your funniest voice.
Oh, hello there. I am Isaac Newton. I've discovered
Smells good.
I hate you both. You will be learning about this video out of this law of motion. My colleagues, Heather,